on our periodic table. In fact, I'm going to check it. Whoops, see, I was wrong. 32.07. Welcome to today's exciting edition of Chemistry on the Back Porch with Mrs. Flint. So, in the other video I did before this one, I went ahead and answered the questions and worked out the problems 1 through 7. And I believe I also gave you the answers. So I'm going to pick up here where we talked about using the dimensional analysis or factor label to do converting mole problems. So we're going to practice some right here, and I'm going to try to be as complete as I can and lead you through the thinking with this. So this is a factor label or dimensional analysis problem like any other. So the first thing we're going to do is we're going to identify our knowns and our unknowns. So this number is given to us, so that's our known. And it's asking us to find out how many moles, so that's our unknown. I'm going to put this in a table. My known goes in the top. So I've got 15 grams of CH4. Ready for my next conversion factor. I know that I'm going to need grams of CH4 on the bottom so that my units will cancel out. Now, I'm going from grams to moles. So the question is, how much does a mole of CH4 weigh? Well, whenever you hear grams, think grams equals grab your periodic table, because you're going to need to look up the values. Whenever you have grams in a problem, you need to grab your periodic table. So right away we know in order to find out how many grams are in 1 mole, because we're going from grams to mole, I got to calculate that. So I'm going to go over here to the side and show my work. I've got carbon atoms, I've got hydrogen atoms, and I'm going to count them up. I've got 1 carbon atom, I have 4 hydrogen atoms. 1 carbon atom weighs 12.01. Each hydrogen atom weighs 1.01, which means I have a total of 12.01 grams of carbon, and I'm going to have a total of 4.04 grams of hydrogen. I add those together, and I'm going to have 5.0 times there. There we go. So my final total will be 16.05 grams per mole. Grams per mole. Whenever I'm calculating this, it's always grams per mole. Grams per mole. You can do this all night, but it'll take a really time to do the video, so I'm going to move on. So I've got 16.05 grams per 1 mole of CH4. I've gone from grams of CH4, those cancel out. I'm left with moles, and that's what I need for my answer. I am ready for the calculator. You put this in the calculator, 15 grams, or so, let's just type in the numbers, 15 times 1 divided by 16.05 is going to be equal to 0.93 blah, 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 blah. Gives us a whole bunch of numbers after that. We have to look to see our significant figures. 15 has 2 significant figures, so I need 2 significant figures in my answer, so I can erase all those. So my final answer is going to be 0.93 moles of CH4. Let's do the next one. This one has a little bit of a typo. There should have been grams there. So this is my known. It's the number I've given, and again, I have to go to moles. Start in the same way I always do. Put my known on the top of my table. If I have grams of NH3 on the top, I need grams of NH3 on the bottom. And I'm going from grams to moles, so I know I'm going to have mole on the top. The question is, how many grams does 1 mole of NH3 weigh? Well, you see, I've got to go over here and calculate this. NH3 has 1 atom of nitrogen and 3 atoms of hydrogen. 1 atom of nitrogen is 14.01. Each atom of hydrogen is 1.01, which means I've got a total of 14.0 grams of nitrogen and a total of 3 times my atomic mass, 3.03. Add them together, 4071 grams per mole. Grams per mole. 17.04 grams per 1 mole. Cross off my units, and I'm left with moles, which is what I need in my answer. I'm ready to put it in the calculator, and it's going to be 162.4 divided by 17.04. And that's going to give me a total of, now I'm going to need four significant figures here. So the number in the calculator is 9.53555, blah, 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 blah. I need 4 significant figures. Now the blah, 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 blah is actually kind of important, and I probably ended too soon. Let me just rewrite that rest of this number here. So when you put it in the calculator, you get 9.53555, and so on. So I need to have 4 significant figures in my answer because of that number right there has 4 significant figures. Here's my first one, second one, third one, fourth one. I look at the fifth one, it's a 5, which means this is going to round that one up. So my final answer is going to be 9.535 is not correct. We need to change that to a 6 because it rounds up. And that's going to be moles of NH3. Put a box around it so it's pretty. Next one, now we're going from moles, which is our known, to grams, which is our unknown. Same procedure over and over and over. 15.0 moles of SO2. If I have moles of SO2 on the top, I need moles of SO2 on the bottom. So the question is going to be, I'm going to grams. How many grams does 1 mole of SO2 weigh? The G for grams stands for grab your periodic table. We got to calculate this one. So we have sulfur, we have oxygen, 1 sulfur, 2 oxygen. 1 sulfur weighs 32.08. So let me go ahead and erase that. 32.07. Oxygen weighs 16. I know that one. So that means I've got 32.07 grams of sulfur. 2 times 16 is 32. Add them up. I've got 64.07 grams per mole. Grams per 1 mole. Back over here. My molar mass was 64.07. My units, they are canceling. And I'm left with grams, which is what I need in my answer. I put it in the calculator, and this time I'm going to be multiplying 15 times 64.07. I've got a 1 on the bottom, so I don't need to do much with that. And that's going to give me a number from the calculator of 960.96. I check my significant figures. This has 3 significant figures, so I need to round my significant figures so that I've got 3 of them. So here's my first one, here's my second one, here's my third one, but it's followed by a 9. 9 is going to cause that 0 to go up by 1. So I'm going to erase this and make that a 1, rounding up. And my unit is going to be grams. I put a box around it so it's pretty. Now for your next one. Now we're starting to change things a little bit here. Now we're not going from grams to moles or moles to grams. We're going to be going to molecules. Same as usual. This is my known. I'm starting with moles. And this time I'm going to go to an unknown number of molecules. So put it in the table. 15 moles of CH4. If I have moles of CH4 on the top, I'm going to want moles of CH4 on the bottom. I know that part. Now the question is, how many molecules are in 1 mole? Well, if you have 1 mole of things, that's going to be 6.02 times 10 to the 23rd things. In this case, the things we're counting are molecules. We're counting the number of molecules, so it's going to be 6.02 times 10 to the 23rd molecules in 1 mole of CH4. I'm ready to calculate. In this problem, I don't need to grab the periodic table. I don't need to do any calculating because I'm not using grams at all. If grams is not in your problem, you don't need to grab the periodic table in these conversions. So to do the math on this, I'm going to do 15 times 6.02 times 10 to the 23rd, and that's going to give me a number of 9.033 times 10 to the 24th. I check my significant figures. I need 2 of them. So I've got to round that, and I'm just going to go around, and I'm going to round that to 9.0 times 10 to the 24th, and that's molecules. So if I start out with 15 moles, I'm going to get 9.0 times 10 to the 24th individual molecules. Let's check out this one. Now, this one we're going from atoms, which is our known, to grams, which is our unknown. This is a 2-step problem. The problems we've done up to this point had 1 conversion factor that you needed to add in. Now we're going to need 2 conversion factors. But let's just lay this out and see how everything matches up. I'm going to do my table. 6.045 times 10 to the 12th atoms. So if I have atoms on the top, I'm going to need atoms on the bottom. So the first question is, I'm going to need to go through the mole. If you remember your mole map, the mole had atoms, the mole map had atoms, and then mole, and then grams. To go from atoms to moles, I have to use 6.02 times 10 to the 23rd. So that's the first step. So the next question is how many atoms are in 1 mole? 6.02 times 10 to the 23rd in 1 mole. You're going to notice that the number 1 always goes with mole in these types of problems because the 1 always goes with the bigger unit. 1 mole is a much bigger thing than an atom. So the 1 goes with mole. Now I'm ready for my next conversion factor. If I have mole on the top, I'm going to need mole on the bottom. I'm going to grams. I want to end with grams. So here's my mole. So we've got grams, so that means grab your periodic table. So carbon has a weight of 12.01. We just have to look that up on the periodic table. And that's going to be 12.01 grams per mole. Grams per 1 mole. So 1 mole of carbon is going to be 12.01 grams. Check my work here. Let me back this up a little bit. My atoms have canceled out. My moles have canceled out. I'm left with grams, and I'm ready for the calculator. To calculate this, I'm going to use my fraction button, would be the easiest way to do this. I'm going to multiply these numbers together on the top, drop down in my fraction, and then divide by 6.02 times 10 to the 23rd. When you do this, you're going to get an answer of 1.206 times 10 to the negative 10. With these, you can get negative exponents. Negative exponents just mean that you've got way less than 1 gram. So please don't think you did something wrong if sometimes you're getting a negative exponent. This is the correct answer, and I'm going to put a box around it to make it pretty. Last one on this page. Again, this is going to be a two-step problem. We're going from grams, which is our known, to molecules, which is our unknown. I start at the beginning, 24 grams of H2. If I have grams of H2 on the top, I need grams of H2 on the bottom, and I need to find out how many grams of hydrogen, H2, are in 1 mole. So I'm going to come on over here. I've got 2 of them. Each of them is 1.01. Multiply that together, and that's going to be 2.02. So there are 2.02 grams per mole. Grams per 1 mole. So 2.02 grams per 1 mole of H2. On to the next conversion factor. I've got mole on the top, so I'm going to need mole on the bottom. So the next question is, I'm going from moles to molecules. So the question is, how many molecules are in 1 mole? How many things? This is a number of molecules. So I'm looking for a number of things. 1 mole has 6.02 times 10 to the 23rd molecules, because that's what I'm counting here. Now I'm ready for my calculator. It's going to be 24 times 6.02 times 10 to the 23rd divided by 2.02. And when you do that in your calculator, you're going to get 7.169 times 10 to the 24th. But we got to check our significant figures. We look back at this number, and there's only 2, which means we have to round. Round, round, get around, I'll get around. When we round that, here's our first significant figure. Here's our second one, but it's followed by a 6. So that's going to change the 1 to a 2, and our final answer is going to be 7.2 times 10 to the 24th molecules. Put a box around it so it's pretty. Right there. So those are 1- and 2-step problems. In class, we went ahead and we worked on individual 1-step problems, and we will continue that tomorrow, and hopefully this has helped if you've reviewed that. Have a good night. It's time for me to go feed the horses.